what's his name, Thomas, mean when he said that it was your idea to channel stuff through EAP?
Well, I have no idea why you said my name, but in the thesis we had this first idea that you can do DPM and then basically any server on the cloud. It doesn't have to be locally. So we use it in a special way to route it anywhere on the internet.
So when we discussed IDU-Roam in the TF mobility in 2004, we had all kinds of ideas how to channel stuff through EAP, and
I'm sure all this has already existed for 30 years.
30, I don't know, but
definitely much before me. Go and blame him. I didn't discuss this with him.
No, I just wondered there was.
I think it was maybe a joke that he's putting me in the tough spot, or because I was like, oh wait, what is this? I think it's time, so we start. It's already 1 past. Good evening. Welcome to LWIG. I'm pretty sure you're all here for LWIG. So this is Mohit and Zen. I'm sure you have seen the note well since the morning, but since it's still Monday, if you want to have a look at it, if you have any questions, please come to the mic.
So yeah, anybody can help us for the minutes taker and Java? Oh, where's Rahul? Yeah, Klaus. Sleeping. So where's Rahul? Can we count on Rahul?
No, he was somewhere, but not anymore. Okay. So maybe I'll go into the other meeting. I can take the minutes.
You can take it. Okay. Okay, thank you. Okay, Rahul is back. It is here. Yeah, here's some updates since last IETF, although we didn't have a meeting last time. And we have a working group last call for the TCP draft, and which has been updated twice. And we are going to report the working group last call update of this document today. And the other draft is related to crypto, and the status of this draft LV curve representations are in the AD evaluation, but we have some discussion with the CFRG research group chair, and I think the current consensus is still, I think it can be processed here, but I think it's a co-shepherd with the two working group, and we will send the IETF last call notes to the CFRG mailing list. And happily, we have two long working group documents updated during this period. The first one is a customs draft on the RFC 17.2.28 bis, and we are waiting. I don't know if there is any request to adopt this document. Anyway, we are going to discuss this. And the other draft is the security classes draft. Anything?
Hi. So, Mohit, just speaking, no hat as a participant, I think we got some information that NIST is also doing something what this LV curve representations is doing. Perhaps John and Rene have more information on this since they follow NIST much more than I do. There is probably some overlap, but that there is no reason why we shouldn't move this forward. I don't know if, John, you want to comment something on that.
Agree? Good. Yes. I'm going to hand the blue sheet. So, oh, sorry. I think the title of this slide is wrong. And so we have some other working group document that has been adopted, but there seems no activity since for this draft. We are going to ask the authors of this draft how what's the status of the draft, and so that we can have a brief plan about each draft. And anything you want to mention about? I'm going to ask one by one. Anyway,
Okay,
yeah. First one is the Rahul's draft on the labor management policy.
Yeah, so we really were looking for the reviews. We had the implementation in place, the performance results in place, but since we didn't get any feedback from the working group, so I mean, we just didn't update it anymore. But if there is anyone interested, we really feel that the problem is kind of important to be handled. We have seen that problem getting discussed on Wi-Fi Alliance mailing group and all that. But to continue any further, we need some sort of feedback from the working group. So that's where we stop.
My suggestion that we can issue the working group last call right after the meeting, so that because people tend to avoid doing anything if there is no deadline. So if we issue a working group last call, probably there will be critical views or helpful views about this draft. That will be helpful for you and also the working group.
That would be great. Thank you.
Okay.
So then we can update the draft, and then
do you need any updates in mind, or
no? It's just I mean we have to send
okay,
the same
yes,
document
to keep
again.
it
There is no new thing. We have already deployed this in production. It's already working in production with the open source and the performance data.
Okay, so I will note this. We will issue the working group last call right after the meeting, and the other one. So the security protocol. How about this one?
Yeah, we have not had time to update this. The plan is, as discussed last meeting, to update it with TLS 102 and DTLS 102, as well as group OSCOR for 2 parties. And I think I have been contacted by, I don't remember which university, but asking exactly for TLS 102 numbers, the new available numbers, so you can compare if TLS 103, TLS 102, there's just high level like 500 bytes and so on. So that's definitely needed. Then the long-term plan, I don't know, ad hoc and CTLS it will take a while before these are stable. I don't know, maybe a year or something. So the question is, do we wait on these? What do we do? Do we remove them and publish? Do we have preliminary numbers and say that these might be updated? Yeah.
Yeah, Suresh Krishnan. So I would say take it off, right? If you're going to wait for it, let it get updated later. I would say just go for it right now. So I think there's value in having this published. So just go and get it done.
Okay, thank you. Thank you. This one fixed. Anymore? How about this one? Carsten.
I think that's ready for working class call. Maybe I should resubmit it so it's not expired, but I think that's all that needs to be done.
Okay. So I think there's another design team in the 6th row about the similar topic, right? Do we need to
Yeah, it's a bit weird that there are 3 drafts covering 2 bases. One is, what does the existing protocol allow you to do? And then there's one new protocol. The new protocol has its own draft, but the existing thing for some reason got split up between 6LO and LWIG. That doesn't make a lot of sense, but it's how this document came to be. So the virtual reassembly document, this one, describes how to do it, and the one in 6LO tells you how good the result is. And the one in 6LO is, I think, has passed working group last call and all, so it's kind of not so useful without this one.
Okay. So I think from this point of view, this one is more practical.
It's not. It's just answering different questions. So this tells you how to do it,
Okay.
and the other one tells you what you get.
Okay, that's a good answer. So, switch.
Suresh Krishnan has like responsibility for both of these. I don't mind holding it until this gets to me before it goes forward. That could be something we do. Or if you think there's value in merging them, that's okay with me too. So Carlos is also here, so he can comment as well. But I don't see why they cannot be the same document. If that's your question.
That's all.
Yeah, cool. So we can work on the specifics. So we'll figure out how to do this.
Okay.
Okay. Carlos, you want to say something?
Carlos Gomez. So yeah, basically in the 6LO session on Wednesday, we have a slot dealing with both fragmentation related documents. So one of the points, there was something that arose from the Internet Area Directorate review, which was related with the intended status for the 6LO document. So that will be one thing to discuss.
Okay, these ones have been fixed. All right, good. Very productive today. How about this one? Is Daniel here? Or anybody on the author list? No? Going to skip this. Oh, okay, this one is pretty tricky because I think I read this document multiple times. I think it's a useful document, but the thing is that the COAP has been changed too much. So with that, do we need to up this document to reflect the ones in the core working group, or we can leave it alone? Custom.
So the intention, of course, was to use this document to collect some information about a protocol that is increasingly being deployed, and within the core working group, we have been discussing that maybe we need something that's more along the lines of, what was it, RFC 4805. My RFC number, I guess, doesn't work today, which was a document in the ROC working group where we, for 5 years, kept it open as an internet draft and collected errors and clarifications. So the work that needs to be done is to redistribute the content between those two documents. So the other one is in the core working group, but not particularly active at the moment. But we have started collecting issues that need to go into that document. So there is some work being done, but just not on the document yet, but on the GitHub repository. And the next step is actually getting these issues over there, and then to look at the two documents and to see which part goes where.
Okay. Yes, the intention, I understand the intention. So, but I don't, do you have any suggestion how to process this document, or we just leave it alive and make it open all the time?
Or maybe someone who can be an editor so that we can poke this editor every now and then if the draft is not being updated, because like the authors clearly have moved on to other things. Document hasn't been updated in quite a while. It's very useful piece of information, but we need someone to kind of see it through.
Yeah, I think that's a good idea.
And you volunteer to be the editor?
Custom is the editor, right? Custom, can you do the job?
Ask me again in February, but in principle, yes.
Okay.
Yeah, Suresh Krishnan. I would say let it die for now. It's like a document. It's like, it's available for whenever, when there's energy to edit it, like we can just revive it and go on. So if like Carsten finds time in February or in June, right, whenever there's something to update, like somebody's going to come back with it, then we update it. Because I think if there's no energy to update it, like, I don't want to be stuck with this document because nobody's going to review it either. So I think it's just let it die, and when somebody needs it, we can just rev it and keep going. Without going through the process again. Okay. That's my opinion.
Okay, that's very good, guy. Thank you. Thank you, Srich. Yes, that's pretty much we have and the custom. So you have updated this document. So what's your intention? Do you want to request adoption immediately for this piece document?
There are several new things in this document. Of course, we already have published 7 to 28. So there are new things in here, and it would be good to get some feedback about these new things. One new thing is security classes, which is an interesting thing given the other draft. But there are also some other new parts about energy usage and about additional classes of processor power. So I think it would be good to get some reviews for that. And then I actually would propose adopting it.
Okay.
So I think before we move forward with the agenda for today in LWIG, maybe this is something for the participants to consider. Where do they see the working group going in the future? Because one challenge I see with the documents is that they are kind of very specific on certain topics. So the crypto document is being driven by 1 or 2 guys who know crypto, but then there's very few participants who are actually providing reviews. The same with minimal ESP or some of the other documents. So what kind of we are missing is having this broad members who can actually review a lot of documents and provide comments. And the participation seems to be going down. So maybe as a suggestion, one way we can think about it is we don't have a physical meeting every time, but only when there is a significant mass of documents that have been updated. We keep the working group alive, we keep the mailing list alive. When there is sufficient drive, let's say from Carsten on certain documents, we can schedule a meeting, or when John updates the protocol comparison document, we can schedule a meeting. But then it's up to you how frequently you want the meetings. We will not ask for a meeting until there is significant mass of documents updated.
So one problem that we have is that standards track documents always override informational documents. So during an IETF week, it's really hard to find spare cycles. Maybe we should actually do virtual interims at some point where we are not in a frenzy getting stuff done here at the IETF, and try to progress documents in this way.
Mohit, like what you said sounds good to me. And if Carsten wants to try it, I think I'm open to it. Just set up a meeting, probably mid-cycle if you want, and see if people turn up, right? But I do see the low energy too, and I think it's fair. Similar thing happened to DHC, right? So DHC had a period where there was not much energy, and then they had a little bit more, right? There's MACAT as assignment came up, and then there's more energy. So it's up to you guys. I'm fine keeping the group open and then just waiting it out to see. Give it a year. That's kind of what I told the DHC chairs. I give you a year, and if nothing turns up, I close it down. So that's kind of the thinking I have here as well.
Sounds good to us. Do you have some comments, Carlos?
Carlos Gomez, not exactly on the question about the future of the working group, but on the point of getting participation on specific topics. For example, for the TCP draft, the involvement of TCPM has been great. So I think that trying to involve participants from the more related topic-related working groups would be great to get feedback.
Indeed, that's perhaps the exception that proves the rule. It has received a lot of comments and reviews.
So let's continue with the additional agenda today. So first of all, we have Carlos to present the TCP usage guidance for the IoT. And Carlos, it's your time. Thank you.
Okay, hello everyone. My name is Carlos Gomez. I'm going to present the current status and the last update of the draft entitled TCP Usage Guidance in the Internet of Things. First of all, let's see the status of the document. The last time the draft was presented was in Prague. That was revision 05. Then around that time, we received comments by Stuart Cheshire and Corey Fairhurst, which led to revisions 06 and 07, respectively. Then there was a working group last call on version 07, and during the working group last call, we received comments by Ingemar Johansson and 2 very thorough and comprehensive reviews by Ilpo and Marco. By the way, thanks a lot to everyone who has given feedback for this document, which has been really useful. So we produced version 08 with the aim to address the working group last call comments, but still after that there were some remaining points. So the last update is -09, which is aimed to address those remaining points. Well, now let's look at the updates in this last revision. First of all, Ilpo had 3 rather minor comments. Basically, he suggested to replace a term pure ACK by another term, ACK without payload. Then the second point was related with a section where we explain that window size of 5 segments is needed in order to trigger fast retransmit and fast recovery. So we have an example there. And however, there was a sentence that could mislead the reader to understand that segments 1 to 6 could be sent immediately right from the beginning. So we corrected that. And also there was one purely editorial improvement suggested, so we applied that as well. Then regarding Marco's outstanding comments, there was a more general comment about a term which was single segment. So in most of the versions of this document, we had been using the term single MSS. Basically, this refers to implementations that handle window sizes and buffers of a size of single MSS. However, in the previous version, we had maybe spuriously changed that to single segment. However, after comments by Marco, it became clear that single MSS was actually the more appropriate term to use here, because it reflects the behavior, what is supported in the category of more lightweight TCP implementations, which support single MSS window sizes and buffers. And also that's what is described and consistent with what we explain in the document. Then in the section where we provide guidance on how to set the MSS, there was a suggestion to change the phrase limit the MTU to limit the IP datagram size. And we did that change. In fact, the MTU is rather a parameter property of the underlying network technology below IPv6. Then there was another comment in this section where we attempted to provide guidance for how to set the MSS when IPv4 is used. However, after a comment by Marco, we thought that it was better to remove that attempt, because in fact there is not an IPv4 equivalent of the IPv6 MTU requirement, so it was hard to provide guidance in the same way. Then in a section that discusses single MSS stacks, we explain that in CoAP there's usually stop and wait behavior. So usually a single MSS window would be sufficient for that use. However, there is one exception noted by Marco, which is that there's the CSM message. This is for CoAP over TCP. The CSM, which is sent at the beginning of a connection, which can be followed immediately by the first application layer message that carries actual user data. So here in this case, depending on the sizes of the CSM and the first application layer message, then perhaps a single MSS window might not be sufficient. Then in the section that discusses delayed acts for single MSS implementations, we have made some clarifications. We had a sentence where we explained that disabling NAGL has no impact if the sender can only handle stop and wait operation. We added at the end of the sentence that this is at the TCP level to avoid potential confusion with stop and wait operation at the application level. And also we applied some additional editorial clarifications. Then there's the section where we discuss the RTO algorithm for single MSS implementations. Here, the idea is that the RTO algorithm that's used may have a greater impact on performance than when larger window sizes are supported. And we already cited in previous versions of the document an algorithm called COCO, which was designed for CoAP, actually. And now we have also added another advanced RTO algorithm, which has been designed also in the context of COCO, which is called Phaser. And also related with the section I mentioned before, where we discussed the window size to trigger fast retransmit and fast recovery. In the previous version, we explained that with limited transmit, window size of 3 segments in the previous version would be enough to trigger sending segments 1 to 5 in the example that we have in that section where segment number 2 is lost. However, Marco pointed out that it's actually 2 segments that's needed as a window size to trigger the transmission of those segments 1 to 5. However, there's the downside of the sender having to wait for the delay tag for segment 1. So that was all the updates from my side. I don't know if there may be any comments or questions.
I guess it's time for us to do the Shepherd write-up and send it forward.
Okay, thank you. Thank you very much.
Thank you, Carlos, and thank you for Marco and who have viewed this draft comprehensively. Thank you. The final item on the agenda is the presentation from Rahul, and there's no draft reflecting this presentation, but the content of this presentation has some insights and can provide some insight to IETF protocols, especially for the IoT realm, and I think we can all learn from something from it, and especially for the protocol designers. Yeah.
Hello everyone, I'm Rahul Jadhav. So this is more of a deployment experiences which we took back and which had a lot of impact on the protocol and protocol designs which we took back to the individual working groups, and we found it lot useful. So this is essentially in 2014 we started off with a project for AMI, and we found that we assembled a protocol stack, we tested it in Kuja, we found that everything is working all fine, and then we tried to check whether it can actually scale. So we had to put up a hardware-based test environment of 300 nodes. And it was really difficult to manage that kind of scale on hardware. And we realized that on hardware, the same protocol stack was not able to scale at all. And then we tried to check what was the problem. And we realized there were a lot of deficiencies in the individual protocols that were not addressed because, especially from the performance point of view, in Kuja, everything worked fine. The network convergence time was great. The node joining time was great. But in reality, it didn't really scale up that well. So that's when we started about this work. It was roughly around IETF 96, 4 years back. And most of the work that we had taken back was for the role working group. And there is one draft in LWIG also, which is about neighbor management policy, which had that particular framework had a lot of impact on it. So what is this about? It's about experience sharing. We have a lot of IEEE papers and other papers online. Most of them are doing the tests in Kuja. I'll be talking why it may not be reliable in certain situations. The results might be untrustworthy. The protocols that are defined as part of those papers may not necessarily be realistic. We have spent a lot of time on fixing those issues, and we really want others to understand what the issues could be. So the experiments, most of the experiments that were done in the existing papers, that they have very limited scope, because there are no frameworks available outside which could actually scale to the kind of number of nodes that you want. For example, if you want to actually simulate 1,000 nodes network or 500 nodes network, there are options available like NS3 or Castalia, Omnet++, but it's goddamn too hard to use those tools. And this is where this is what exactly we had been through, and this particular talk is about those experiences. So my context here, we started off with multi-hop mesh routing protocols. We had big networks, 1,000 nodes. We aim to reach to that scale of 1,000 nodes with 16 hops, a typical AMI scenario. So this is what we thought. What we want is from this framework is, we wanted something which we can benchmark for, and we can have other people's submit their data, their results, or their experiments in the same framework so that it can be compared in the same context. This was the most important thing. We wanted something to be reproducible. The data should be reproducible on a different system. Data should be under realistic network condition. When I say realistic, it's still simulation, but with realistic path loss modeling, with realistic interference and collision modeling. So that kind of realism. You can, of course, use the real hardware, but to deploy real hardware with 500 or forget even 500, even 100 nodes requires a lot of manpower and requires a lot of not most of the teams here could muster that kind of energy or that kind of resources that are required for a hardware testbed. The next important thing was the interop testing. We wanted to test at scale. So we have a lot of open source options available. We wanted to check if those open sources could actually interwork with each other at scale. So in most of the interops, you would see that there are few nodes kept on the desk. They talk to each other, and that's how we prove the interoperability. But at performance, but if you want real performance at scale, if you are putting to 100 nodes, a lot of protocol-specific idiosyncrasies that come up, which results in a very bad performance eventually for the whole network. And we wanted something wherein a scenario configuration could be shared to other developers. They can just take the scenario configuration and start from there and get the data. So we understood that realistic models are necessary, especially for wireless constrained networks. Some characters such as asymmetric links, impact of channel access, interference and collision patterns could have a really, really big impact on the overall protocol design. Performance data is important to be measured, but best is to use hardware, but it's not always possible. So these were the premises where we built upon. So now that we're talking about yet another framework, I should explain that there are a lot of framework already in place. For example, the Kuja. It's very good to use. It has extremely good visualization, and that is why we could see that almost 60 to 70% of IEEE papers give data based on Kuja. And it integrates very easily with the existing most popular open source operating system called Contiki, and it makes it very easy to use. It supports hardware emulation. That is another feature that it has, but it doesn't really have any realistic path loss modeling and propagation models. It cannot scale to hundreds of nodes. It works on top of JVM. If you try to put in hundreds of nodes, it's going to just die off. One good option is to use NS3 Omnet++. These provide you realistic options, but it is impossible to use the real network stack. If you want the network stack from Riot or Contiki or any other Linux kernel for that matter to be used on top of NS3 or Omnet++, you have to port your code in context to NS3 or Omnet++, which is a really, really big ask. It's a big work in itself. So there are certain options such as NS3 provides something called as tab bridge, but these options cannot scale to hundreds of nodes. You can't have really, you can have hundreds of tap interfaces, but it's really an ugly way of doing doing at that kind of scale. You don't want 1,000 tap interfaces on your machine just for simulation purpose. There are hardware-based test beds in Indria, FIT, IoT Lab. You get practical data from that, but you have limited scale. And the access to those test beds are rather limited in the sense that you can't really play with it. You have a confined time in which you can operate on them. You can't really change configuration and quickly check the data. So realistic simulation frameworks are difficult to use. Here is the data from one of the papers which had been recently submitted. If you see, Kuja is the most dominant tool. NS3 is also the second most dominant tool, but Kuja beats everyone else by a big number. It's 63%. You see the data, the graph on the right-hand side shows you how many of the experiments had actually used hardware. Less than 40% of experiments have actually used hardware, and 80% of those experiments use less than 60 nodes. So if you see most of the documents in a lot of working group talks about scaling to thousands of nodes, while there are no practical frameworks which can actually deliver on that task. So this work we had started during IETF 96. It's called Whitefield. And this is basically how it operates. You have the realistic protocol stack, Contiki Riot, and then you have NS3 or Omnet++. Right now, Omnet++ is not integrated. Only the NS3 is integrated in this. You can use real network stack in this, and the same network stack can be as it is migrated to the hardware. So the advantage is you'll be able to experiment with, and it can scale as well. It can scale to 500 nodes on a regular laptop. It supports NS3 as of now, but it can support ideal air. Ideal air is a context in which you can actually have configurations which can be shared to everyone else. You have deterministic models where the same thing can happen over and over again, and you can share the configuration to someone else. Question?
Abhijan?
Yeah.
I have a generic question from the previous slide. The statistics that you have shown over there in that pie chart. So the small amount of qualnet percentage for qualnet, I mean, is it because of its qualitative reason, or is it because of prohibitive cost? I mean,
I don't know about that because the paper doesn't talk about it. This is the data from the paper that I've
no,
mentioned.
what I want to know
But
is
the cost
that
factor.
have you evaluated qualnet in terms of its properties, the offerings that it gives, or is it only that academicians do not use it much because of that? So whether that kind of an analysis has been done?
So especially you're asking specifically in context of Qualnet. Qualnet we have not evaluated, but we have done experiments in Kuja, NS3, Omnet, and WSNet as well.
Because I'm also attached to university, and Qualnet is a pain working.
Qualnet is a pain. Yeah, all right. Yeah, I don't know whether Qualnet is a paid. It's a paid tool. I don't know. I don't even know about that. Okay. Yeah. So this is what we have. Essentially, what we have is we have individual protocol stacks operating, and we have a virtual airline which operates only the physical and MAC layer inside the airline. And the network stack, whenever it delivers a packet, it's delivered to a corresponding virtual node in the airline using a message queue. Right now, the message queue is implemented using abstract Unix domain sockets. But the realism, the wireless realism that you get is from actually the NS3. But the best part is that you don't have to change your code, or you don't have to change your design to suit NS3. You can use the existing protocol stack in context to NS3. So that's so Contiki Riot and Riot is already supported. OpenThread support is in progress. It's still not there. Every stack line here is an individual process. So what we do essentially is every stack line, for example, Contiki, we have added a platform support for Whitefield. It takes the packet from Contiki and sends it to the NS3 corresponding virtual node in the NS3, and then it goes on to the target node, and then it comes back to the stack line again. So maximum 60,000 nodes could be scaled, but we have practically tested it for 1,500 nodes as of now. We don't have a machine that powerful to run 60,000 nodes, but anyways, we have run it for 1,500 node at max. The airline, stack line, and communication line are all decoupled such that the new stacks could easily be added here. We have planned to add Zapier as well in the near future. We have tested interop between Contiki and Riot in this platform. So this is how it looks. There are a lot of configuration that has to be input in this, but what we are trying to do is we're trying to synergize, or we are trying to give all this common configuration to the Whitefield core, and then let the Whitefield core give you the results. The ONM is same across all the stack lines. So even if you use Contiki or Riot, your ONM is the same. The Whitefield integrates with all the ONMs for individual stacks. So case study 1, so this has been one of the most important draft that we have been working in role. Most of the data that we have gathered for this particular work has been taken using this framework. Without this framework, it wouldn't have been possible to get the kind of results. For the first time, we were able to test interop between Riot and Contiki at scale, and we found a lot of issues. So the primary issue being that the DAO aggregation is not handled in Contiki, so there is some messaging that needs to be handled. So it's not handled. We reported that RQL DAO fragmentation issue on Riot mailing list. This was discussed like an year and a half before. Essentially, we couldn't interop at scale. Network convergence time for 300 nodes, Contiki nodes in Kuja, it reports less than 20 seconds. If you use Kuja, but if you try to do the same thing with Whitefield or with with real hardware, the convergence time is in minutes. So there is clearly a major difference between what you see in the simulation platforms versus what you really get. Control overhead was very different. So the control overhead when you test it with Kuja is very different. You get very little control overhead because there are very less losses. The interference is less. There are interference models, but those are not realistic. Case 2, we have NPDAO, which showed the impact of optimized invalidation on overall network. The actual numbers with Kuja were really, really nice, but we couldn't report that. We had to report some realistic data. So our numbers were much different from what Kuja could have actually produced. Neighbor management policy, the draft which we have here in LWIG currently expired, but yeah, so we showcased, we already had presented our performance data last time in LWIG. It's about the impact of neighbor cache policy on the overall network stabilization. How stable your network will run if you have limited neighbor cache size. The minimal fragment draft, again, we had presented this in LWIG as well as 6LO before. It shows the impact of 802.15.4 single channel mode of operation on fragment forwarding. So all this data, all the data that I'm talking of is available with the detailed configurations and observations and the raw data on the same Whitefield framework GitHub. So there's another interesting piece of work which started last year called as IoT Bench. It's a community effort to better evaluate and compare low power wireless network. The principles of IoT Bench and Whitefield are more or less similar. So basically, the aim is that the developers, the implementers, should be able to share their configuration, share their observations, and the data should be reproducible. IoT Bench provides an excellent conceptual framework. It clearly abstracts what are the configurations that are required, the performance metrics eventually, and Whitefield going forward will try to use a lot of recommendations from this work. That's it. If anyone is interested, here is the details of the framework. It's completely open. It's a GPL license, and it's completely driven from
Mohit, so I found this presentation and the whole work very useful. My question is actually to our AD Suresh, and do you think this is something we could publicize within the IoT blog that Steve writes? Because I think this has implications across several working groups. So based on this kind of more real world simulations, we had these drafts which were then affecting these working groups, kind of showing that why having realistic implementations in the IETF is our way of working.
Yeah, Suresh Krishnan, I think I can do even better. We can go on IETF.org blog if you want, right? So we can, I can like introduce you to Greg. We can probably write something. We've done this before. We've done something for LP1 Like we wrote like an article, like I sat down and with Pascal and Alex and wrote something. So if you're interested, like, I'll talk to Greg and we can figure out how we want to write about it.
Okay.
Okay.
All right.
So it goes on IETF straight up.
Okay. Okay. I have one more question in the context, if the time permits. So is one thing that we had been thinking is it possible for us to give the benchmark configurations as part of IETF draft and say that, these are the benchmark configurations that one should test if one needs to?
Sure.
is this
Like
something-
there's been like a lot of drafts, like especially like earlier in the IETF, which had like test vectors directly in the RFCs. Like, so I think there's like pre-existing stuff for that. So I don't see why not, right? Like that you can publish this like configuration kind of thing. I don't see why it should be an issue. But a blog entry would be just as good, I think, right? If you can publish it and we can reference it somewhere, it should be okay too. And it's pretty much permanent as well. So I think it's like a really good vehicle for this.
Okay.
Thanks,
Thank you.
Mohit, for suggesting it.
Thank you. Thank you very much.
Thank you, Rahul.
Sorry, before, where are the blue sheets?
Okay, the session ends, and thank you for coming. And thank you for coming. And have a nice evening and the week ahead.